I am muted. So this is a replacement talk called Drop Database Galactic Story. But even though it's replacement, I think it might be quite interesting to you. So like 2 days ago, I was doing a talk about Lambda Hardcore. And that was very useless, but I hope interesting thing. So this one is opposite one. No, it's completely useful and uninteresting. No, I hope not. You will tell me. So let's start. Short about me. My name is Jaroslaw Ratajski. I am developer, wizard, an architect. So I live in Lucerne. That's a city. Yeah, below the mountain on the lake, and on the mountain there was a dragon. You get the point. Of course, there live dwarves there. I work for CSS Insurance, also known as CSS Versicherung. Yeah. So that's my, I would call them Pokemon. So technologies I play with, all of them I hate, I think. Yeah, and that's my email and Twitter. So if you have some thoughts, want to share something, just do it. So, before I really start with my presentation, I want to introduce you some concept. Multiversum, who knows what is this? This is a physical concept, you know. As 2 days ago, this man knows everything. But okay, so, very easy, because it's needed for a presentation. You know what this is? From physics, chemistry? What's this? Yeah, so, oh, you are very exact. So orbital, it means a probability density. So if we are trying to spot an electron in some kind of atom, we may spot it in this area. So the more dark it is, the more probable is to find it there. So it like to show you, we may spot with some probability the electron there, or we can spot it with even better probability there or there. And it's quite unlikely to spot it if we are doing observation somewhere in this white area. It's like this. So this is this randomness of quantum theory. You've surely heard about it. So let's pretend we are doing some observation and we spotted electron there. And there are some people that hate this idea of randomness. How can it be random? There must be some kind of machinery inside. But till now, nobody found this machinery. So it seems to be totally random, but why there? So there is one interesting answer to this problem. The answer is there is no randomness. In every moment we do such observation, what is happening with the whole universe? It forks. You know the Linux instruction fork? What it does? It splits the process into two same looking processes that go farther the same. So in the moment we are doing observation, the whole universe forked. And we are like this child process, one of them, and we see the electron there. But there are some parallel universes created, forked. For them, they see their history different. They see this electron in other places. So like this is a way to avoid randomness. There is no randomness, that's only forking of everything. And if you think about it, it's quite funny because maybe that was one sample, electron was there or there, and the next moment we do further observation and maybe we observe it in other place. So this moment, this story of this atom was forked 4 times. That's simplification because it's not the story of the atom that's forked. This is the story of the universe, of the Earth at least, and maybe more. So in every moment, only because there's one simple electron, we fork everything. It's huge concept, very interesting. And it goes farther. So this theory, multiversum, simply says that the whole universe, really, is because of those observations made on the so small scale, every moment forks incredibly. That's massive Iber fork of forks. Is it right? Yeah, thank you. The man that knows everything said that I'm correct. Yeah, I'm not really a physician, so for me it's like talking further about the things I've seen on YouTube, in the books, but nevertheless. So it's this massive multi-fork is called multiversum, and what's interesting about this theory is that, and very important, that we only see this one chain of events. In this moment, I see only one chain of events, all others are parallel universes forked, are not visible to me. So maybe in one of these parallel universes, because of something happening, I don't know, yesterday at the party, I'm not even doing this presentation at all. But you don't know this. You are lucky because you are here and you see my presentation. Okay, so, and because of that, because we cannot prove those universes are really not touchable, we cannot contact with them, this theory is completely useless. But it's nice to hear about it. But let's go back to the reality. So let's think about something from the real life case. So there is this galaxy. It's quite known, in Poland at least. And there is this guy, is the galactic-wide known businessman. His name is Domino just. And he has idea of creating galaxy-wide pizza delivery. It will be called Galac Pizza. Just normal business, yeah. So let's talk about this business. So like, yeah, we'll be doing some real stuff. So the business is in the galaxy exists like 10,000 planets. Okay, the 10,000 planets where the creatures, aliens, eat pizza. There are other planets, you know, galaxies are huge, but there are no beings there interested in pizza, yeah. Poor aliens. But 10,000 planets surely can order pizzas. And there are 3 variants of pizza. As you see, the most important one is Hawaii. Who likes Hawaii pizza? Oh, am I the only one? Margarita, of course, and vegetarian. Just no, not to forget about vegetarians. Of 3 sizes of pizza: medium, large, and extra large. Of course, the small pizza makes no sense at all. So good businessman knows that. So that's our domain. 10,000 planets ordering pizza with 3 variants, with 3 sizes. And by the way, that should be made a very simple system that, yeah, alien being, like, yeah, alien creature can order 1 pizza at a time. He can choose, it can choose. For instance, margarita, large, to the planet with some kind of fancy planet name. That is our domain. And there is one more important thing to this domain, because this businessman, Domino, he doesn't like to give money too much. He has only 1 pizza boy with 1 racket. And he thought it might be very smart, if there are alien creatures ordering pizza, to deliver this pizza first to the most demanding planet. The planet that requests the most pizza should be served first, like this. So in our domain, we have some constraint that the pizza boy with this racket should surely, if there is a huge queue of orders, should surely go first, not the first that ordered, but the planets that at this moment order the most pizzas. That's just our requirement. So in this case, he would go to this brown planet first, then to the second. I don't know the color because I don't see them. But because there were both, we have 3 pizzas, and that at the end to those not really profitable planet with only 1 order. I hope it's very easy to find out, yeah, how it works like. Yeah. So the pizza boy is in fact very, very quick with this racket. You know, that's really cosmic technology, it's a galactic technology. So he made it in no time, like travels back again. The only problem is really the speed of the system that will be accepting these orders and will be used in processing. So this system must be very fast, said the guy. Like, it should be able to process like 10,000 pizzas per second. Like, so 10,000 orders made at least per second should be possible. And this guy taking should be able to say, yeah, I'm taking, for instance, these 3 pizzas from the most demanding planet, and it should totally make this true output of 10,000 pizzas per second. By the way, who is working with systems that process like 10,000, I don't know, orders per second, normally, among you? Who is working with systems that process 1,000 orders per second? Okay, who is working with systems that process something like hundreds per second? Yeah, that's more typical. In most cases, in this galaxy, boring galaxy, we do things with systems that process some. It's even now then big, 10 things per second, 20. By the way, who is working with Java EE stack? So I was many times trying to tune Java EE systems to process something like, I don't know, more than 10 per second, because it was almost impossible to reach that speed. But we are talking about 10,000. Okay, so right now, why did we have this concept of multiversum? Because we'll be now following the story that happened in two parallel universes. Because I was there, so I can tell you what happened. So there is a normal universe and other universe. And in both universes, there were, the domino, the owner of the business inventor, gathered the group of coders, alien creatures that can code in something. Normal case. So, and he explained them domain and the requirements and everything. And then developers were asking, how do we do the system? In a normal universe, they have chosen Java. By the way, who is a Java developer here? Great, it's especially for you. And the other universe, guess what they choose, what they have chosen. Plus plus, but they've chosen Java plus plus. We'll go further, what this topic means. Okay, so let's go to the normal universe. By the way, the code, I was able to fork this code on a GitHub, so you can see the code created in this normal universe on a GitHub under this address. So no problem, you can check it later. And in the normal universe, the alien developers started with modeling the domain. What is the domain in this case? You see, it's order. It means the most important object in the system is order. Like, as I said, the alien being, not the human one, can order one pizza at a time to some planet with some variant and some size. By the way, as you see, it's not Java Bean. Who is not using Java Beans anymore? Oh, great. You shouldn't use Java Beans. They are just stupid concept. So this is immutable object, which really is great in working with. But okay, that's another story. And by the way, they added some kind of ID to the orders, because you know, everything should have ID. I don't know why. Those are aliens. And though that's enums that we need, it's very obvious what kind of, you follow, you understand this code, it's very easy. Nothing really was happening there. So, and then they were thinking about the behavior, what kind of services should they provide. They have first defined the interface for the customers. Long place order for which planet, which variant, which size. As I said, it means for one pizza. So if the alien creature is organizing a party and needs 20 pizzas, this being must order 20 times. It's okay, it's that easy. And then it gives back some kind of ID, whether it's needed or not. And then they were thinking about the back office. By the way, I forgot to tell you about one other thing. So take orders from best planet is something for the pizza boy. So every time he goes back with his racket and he is about to serve some other pizzas to transfer them, he uses this function and gets the list of orders to best planet and travels to this planet faster than light and goes back, and then again uses this function. And by the way, I've skipped this requirement. It should be there somewhere. Let's go back. This below. The domino says that they want to constantly look at how many standing orders are there. Maybe the queue is too huge. Maybe he will need another pizza boy or whatever. And he will be checking like 10,000 times per second. And by the way, his wife also. So it makes 20,000 per second. But okay, 10,000 per second are needed. So we'll go back again to this story. So because of that, there is this count standing orders that returns along. So how many orders are on the queue waiting? Simple like that. I hope it's easy. So they even made a global interface for something called Galactic Pizza Service with Galactic Pizza Delivery and Galactic Pizza Orders. Like this. So they are starting to implement it. So how Java developers can store orders somewhere? So like for every planet, I should know how many orders are there. Somebody has an idea? Give me ideas. Multi-map, okay, so yeah, That was their initial idea. How did you know that? Okay, we are working together, almost. We should be. He reads my mind, really. Yeah, you've been there. Okay, so that's kind of a multi-map. We have a name of the planet here and list of orders. And that's a hash map. Who knows the hash map, by the way? Great, so it's easy, yeah? So they started with this, but it wasn't, in this implementation, it wasn't very useful, because working with this list directly was kind of not pleasant, so they created some other supplementary class called planet orders. It simply hides this list. So planet orders is like name of planet and orders, and you get the point. And assign order that adds to this list something. So because in Java it is not that easy to work directly with this list, this implemented, so with that kind of utility object it was easier. So, and method is empty. So how was place order done? Very, very easy. You know, place order, we have a sequence that is just a long, we increment it, we create new order object, then we call method assign order to planet with an order, and then we return ID. So let's see how this assign order to planets looks like. We have an order, then from these orders we call funny method. Who knows compute if absent? Yeah, you should know that, because typically in Java, what would you do? You would check with if there are orders to this planet at all. If you find this object planet orders, then you will add it to this list. But maybe there were no orders to this planet before, so you get a null. Null is the bad thing. So then you would what would you do normally? If get from orders is null, then create new planet orders, put it into this map, and then assign to it. That's quite few lines of code. You can replace them with this small construct, this method, compute if absent. It exists since Java 8. You say to which key, and what would you do if the thing isn't found there? So compute if absent works like that. We look for the object with this key. If the object is not there, automatically will be created here and added to the hash method, then returned. So it makes our code very easy. We don't have any ifs. It's perfect. Really, that's functional solution. It's possible with Java 8. It's great. You should know this. Okay. So then they were thinking about this counting orders. How many are in the queue? So initial idea was to create another long thing, but then they realized might be a problem, so they used atomic long. Who knows what an atomic long is? Yeah, great. So generally it's safe for the multi-threading use. So just like long. So in this place order they increment it simply like that. Why it's atomic long I will explain later. Why the other long is not atomic. So then they were thinking, okay, placing orders is easy, but how can we retrieve which planet has the most, at the moment, he's demanding the most pizzas? So should we go along this hash map, along all this list, and just sort them? Of course, it would be possible, but it would be slow. They in fact tried it, and it was slow. So they realized they need some kind of a structure, something that they can easily always take the best planet from. You know this structure maybe. Who knows that's magic? In fact, it's not magic. Yeah. Data structure that you can put objects, and they automatically are sorted inside. So every time you pick from it, you get the best one. Then you take another best one. What binary? Yeah. And in Java, there is a class that exactly has this implementation behind. What? Okay. Once again, what? Exactly. I am talking about priority queue. So behind the priority queue, you have this tree, but the priority queue interface is like really put something and always take the best one from front. So it's interesting. You are Java developers. and only one of you know about the priority queue. Think about it. It's quite long known class. You've never needed before priority queue. It's interesting. And you never needed before compute if absent. Of course, compute if absent is something new in Java 8. Okay, it's not really that new, but priority queue exists like 15 years. I think it's quite useful, but you never needed that. Okay, so they simply implemented like that. Every time they assign planet orders to planet, they put this order to the priority queue. In fact, with the whole planet orders. And it would be okay solution. It would even somehow work, but there is a problem with priority queue. Okay, it's not a problem with priority queue. Problem with this implementation. If you have something in priority queue, and we sort by the number of pizzas inside for each planet, such object may not change because these things we are sorting for cannot change. If you put something in a planet in this priority queue, it must be generally immutable. So not the whole thing, but the thing we are sorting. If we don't do that, it mutates. So like for instance, the planet had 5 pizzas, and then we change it to 6. It will work, but will behave not according to the contract. It won't give that, for instance, the best results, or it will be unperformant. So there was a solution for that. I say this is very bad concept to put planet orders that then I later changed. So they created something like planet order wrapper. It's simply like memento. We store how many planets we had at the moment of putting, and it stays like that. So it's very easy object. It's final int. You see final never changes, and such objects we put to the priority queue. Okay, and then I will not explain you all the details. We have more important things, but generally take orders using this was possible. So first on this list, they implemented take orders, like just take all these orders, assign the new array list because we simply clear everything for this planet and return what was there. We have a method, a supplementary method is empty. Yeah. By the way, we mutate planet orders. We don't mutate this exactly these things that is on in the priority queue. So it's like a trick. We mutate this object behind, but not the thing we are sorting. And then here is quite funny code. We take the best thing from the planet's orders. If it's null, then if it's not null and not empty, then we can use it. If it's empty, then we can just look for another. Or maybe we'll, by the way, who is using optional at the moment? Great. You should, in a new Java code, you should never use null on your own. I had to use null here because I am talking to the very old and nasty class designed by some Java developers. But I would never right now design my class so that it returns, the method returns null or accepts null. That's a just bad idea. That's a mistake in 2016. So even here, if I am talking to priority queue, I wrap it so that I don't return null, I return optional from planet orders. Learn us, you shall never return null. A lesson. Okay, but then they made it, this code, I really skip it. So it was possible to efficiently take the best planets because we had some other supplementary construct. We are not working directly on this hash map that is our storage. We are working on this additional object, which is, by the way, simple index. We can call it just index, and we use it for searching for the best planet. Okay, so, and by the way, take orders from planet. At the end, if we take, I don't know, 6 orders, we decrement this orders total. We subtract something. So counting orders, so how many orders are in the queue was very easy. Like we just use this orders total atomic long and we return the thing. It's incredibly easy. So almost done. They even did a test for that. But you may see some problem with this implementation. Who sees a problem with this implementation? It's a perfect Java solution, but might have a problem. Think about putting it on production. Where is the problem? Restarting, because what? Hash map would be, not there. Other problem? So generally, 2 problems. At least I know about two problems: concurrency and persistence. Typical problem. And right now, this group of alien developers luckily had one experienced Java developers among themselves. And they told them, you know, it's easy. How can that be easy? Because they introduced a little bit of magic. A little bit of magic is some interesting thing called persistence controller. It's a class. It's open source. You can find it later on the GitHub. We'll not go to the details, how it looks like. Well, it doesn't matter. I will tell you how it works, because it works very, very simple. So what they do, they had something, they had implementation of Galactic Pizza service, but they implemented it once again, but this time with concurrency and persistence. How? But using the other implementation. So how did they do that? Here they initialize this thing. It's not really important, by the way. It means here stays where on the disk it will be written, but it's not important. Let's analyze the place order. What happens? We use the controller. We call the method that is called execute and query. Then we get something core. What is a core? Core is this object, Galactic Pizza core. So implementation, in fact, of the same service that was written in plain Java without any persistence, whatever, on the hash maps. So execute and query work on this simple Java thing and calls place order there. So we only delegate. We don't do anything interesting. We only delegate. Put it further. But there happens something. I tell you a little bit of magic, because this execute and query does one more thing. Okay, two, because we have two problems. First of all, this is a lambda expression. And who has used lambda expressions in Java? Lambda expression is an object in Java. Objects in Java you can generally save. Using what? Who knows? Easy way to save something. Serialization. That's a lot of people criticize it, but it's very, in fact, powerful. I don't really completely like it, but it works. So what they do, they first of all serialize this thing on the disk, so store it. And by the way, they don't store this thing doesn't store the code. It's not code that is stored. It's simply what is stored there. It's like something like the number of lambda expression, so some kind of reference. In normal cases, just the name of class, and then all the needed parameters, so planet, variant, and size. These three things. So it's like, otherwise it would be simply on the disk that I did place order and with three parameters. That's everything that is needed to reply it to just know what's happening. So this thing is stored on the disk. And then it's executed. Simple like that. So if we take orders from the best planet, it happens the same thing. We first store on the disk. By the way, this time we only need to store what was happening. Take orders from the best planet, no parameters are needed. It just goes like that. So we just say that it was this method called. And one more thing, those methods, execute and query, are completely thread safe. It means only one, in fact, at the time is working with something. So in fact, there is a little bit of code that you can store multiple at a time, but only one is executed. So everything that happens here inside of executed query is guaranteed to be only to be processed one at a time. It's very good because it's then we don't have problems with concurrency. But then you have queries. So at the end, we are calling this count standing orders. And you know, queries, you don't have to store anything. You just query, so you don't change the system. That's basically this idea of this query. I hope you see this. So they are saying what they are doing, the counting standing orders. They get the result, and it will be called. By the way, this query is not really needed. You can call it directly, but it was just to make it somehow consistent. So query, in fact, does nothing. It's no magic there, in fact. That's a typical delegation. Okay, I hope you more or less understand the idea. Let's store what we are doing with all parameters and then do it. And this way, they have at least some kind of a log on the disk, what was happening with the system. Everything that happened with the system is stored in this log. And it was done. Okay, so this thing, and the normal universe, I call it normal with Java, was done. System was working. We'll go back there later. So let's take a look at alternative universe. By the way, I also stole the code from this alternative universe. I've stolen and inserted it on the GitHub, so you can check it and you can see it. So it was this Java++. What do you think is Java++? Who knows this, more or less, what it does? So who is using JPA in his work, or know how to use JPA? Okay? So Hibernate, other object relational mappings, who knows? Okay. Give me a name. Interesting object relational mappings. For Java, best. Okay, that's more or less the same. It's more or less the same. So this time the group of alien developers tried to model the domain. As the other group, in this parallel universe, they realized that the most important object is order. So in order to preserve, to model order, they created class order. How simple. And of course, in this universe, they believed everything that exists must exist in a table in the database. So they added some kind of magic annotations, like table. And by the way, they needed to use it because if it's SQL database, the table cannot be named order. It must be, because order is reserved keyword. So they had to use it T-order. It's a really nice concept. And then they did it. Okay, we'll go further with these name queries. Maybe you know what's this. It's looking like SQL. And then these implementations look more or less the same as the normal universe. There is only a little bit more magic, like entity, named queries, table, this generator, and this is the most funny thing, because somehow in year 2016 JPA you cannot really do clean objects with immutable. You have always to give at least this protected constructor without parameter. This is really crazy. So you had to fill with some crazy data like nulls for no reason, because in fact this constructor is in fact never used. It's only needed by the framework. So it's really crazy for me. Yeah, why then? But it's not really, because for serialization you don't need it. Sure. Surely not for okay, serialization in Hibernate, whatever, maybe, but for a normal serialization, surely not. So that's the attitude of the guys. They love Java, but they must do everything in SQL. So as you see, at least the other things in the domain were the same. So they even later tried it. So it's MySQL select. You see, it works with MySQL. Great. So because there is a table, it means the system work exists. So they are satisfied. They were working for real this time because they have table. Yeah. So if we go to the other services and things like that, you see some similarities because the way of thinking was somehow the same most of the time. So selecting the best planet, maybe. All of was simple, but how they select the best planet? That was the first approach. Select, blah, blah, count from group by count. Is it okay? Solution. It would work, but wouldn't be they tried it that fast. So they realized they need some kind of another table that would really help them to sort those best planets. So you see the similarity. So they created this planet structure that has a name and a counter. So they can now sort this table, and it was all with this solution a little bit faster. In fact, way faster. So it worked. And then they started to implement. It's this kind of implementation you can see everywhere. It's quite common. I won't go to the details, like whatever you do, theoretically everything in Java, but in fact all that happens in select queries and with JPA, persist and things like that. There is a lot of magic happening there. Like, for instance, I can show you one funny magic here. Because they realized if there were no orders for the planet and it is executed concurrently, it might be that twice in the same times are inserted the same planet structure with the same name. Then they have, how it's the constraint violation exception because the same name already exists. So in fact, they invented functional, very, very funny way to do that. They use this, do this function that takes a session, that's a Hibernate session, and with a function that's db command. So they execute this db command, it works, and in case of constraint violation, they re-execute it once again, because this method is looking like, does there exist this row in the planet table? If exists, that increment counter, if not, insert. So sometimes it happens that two transactions see there is no such row, so insert, and both insert the same planet. With this case, you have automatically retrial. So maybe they will do the same 2 times. Both think, okay, doesn't exist. Both insert the same planet with a counter 1, and then one fails because of constraint violation exception. So what happens then? The whole command is restarted, but this time it reads from the database, select from planet with this name. Oh, it's there! So right now it works. So it's a really nice pattern. By the way, they don't use JEE, they don't use JPA, that's directly Hibernate because of the performance, and because of this thing. This nice thing allow them to do such tricks. It's really nice thing. So take orders, let's keep it just normal SQL code. As you see, a lot of magic with strings, selects, even though they use name queries is at the end a string somewhere, and some annotations. So they did some Hibernate config, MySQL configs, and things like that. You will see in the code, generally, if you look. So after 1 day of coding on both universes, yeah, come the reality. They started into the production. And by the way, we can simulate what was the production with a simple, I wrote in a simple simulator, so you can check it on your own because there is a Galaxy simulation cluster that simply does the things. Simulates customer, like 4 threads, constantly doing some random place order, thread for the pizza boy that's doing constantly take best orders, and 2 threads for owners that constantly look how many things are there in the queue. So why 7? Because this simulation is designed to be working well with 8 cores processors. Simple like that. It's not, by the way, I really spent a lot of time to make this simulation and benchmark quite good. It's not that easy to do good micro benchmark. There are a lot of pitfalls, but I think I used a lot of my experience. If you find there any problem or whatever, just tell me. Maybe we'll resolve it. But this was the simulation. And of course the real life. So there is some code like making the JVM warmed, yeah, then really processing something. Okay. What happened? Let's go about in the real Galaxy. What happened? Processed order. How it would work? Do you have some clues? What was faster? How much faster? Okay. So in the normal universe, world of Java, they achieved 40,000 pizzas per second. For a typical system, of course, there was in this measure there is no, for instance, HTTP calls or something like that. It's just plain Java. Nevertheless, it's quite interesting number. So in the other universe, they got something like 600. By the way, it was on already tuned MySQL with some tricks. So it was not the first number they have seen. Nevertheless, that was so that's how I would say writes. So these processing orders work on both universes. You see the difference. Does it make a difference for you? Yeah, I think it's quite visible. And so in the first case, of course, the owner was happy. It's 4 times better as he wanted. In the second case, yeah, you see, he wasn't that. So no free beer, no pizza, just punishment. And remember, aliens do not have human rights. So this peeping spell, observing, if we only read, you know what was the result? I really spent a lot of time to prove it's not fake. It's not some kind of artifact from JVM. It's not, because this really, so many times you can read along, because really there is nothing more there. It's like almost empty code, almost empty. So then, in this other universe, of course, it was 6,000. It was, so reading, as you see, is way faster than writing, of course. But in this universe, it's like 1,000,000 times faster. In the second, okay, million not, but really 100,000 times faster. In the second, it's like 10,000 faster than normal writes. But at the end, difference between reading here and here is like incredible. Nevertheless, as you see, here was really happy. And yeah, no, that's not what I wanted. So, in a normal universe, they started their production on this laptop. I stolen them from this laptop from them. It's okay, because it was enough. It was absolutely enough. Another universe, they were looking for some server rooms, whatever, to make it somehow working, but they had this problem with the one database, MySQL, whatever they did, it wasn't really performing well. So in a normal universe, they even went farther, okay, maybe to the other universe. They tried to tune it a little bit. They hired MySQL consultant. In fact, in this world, the best MySQL consultant is a simple script that you can run that tells you what you have wrong. The research script really helps, and then you can read that book that helps you to identify further problems. At the end, there were only 2 tables. So it's not that horrible to find out that finally they found some ways to make it perform better in this other universe with MySQL, mostly with tuning MySQL, caches, buffers, and things like that. In normal world, by the way, they also profiled Java, by the way, in other universe also. And they found out they had a bug in performance. It could have been faster. So after, let's say, 1 day of struggling with the performance in both cases, with one just because they drank a beer as a gift, so they wanted to see. They achieved this in the normal universe, 60,000 per second. So the code on GitHub, in fact, the last version, it performs like that. And it wasn't a big problem because those was Java profiling, really easy. In other case, they almost made it to the 1,000 per second on this laptop, but it was close. It was not really, but it was close. So let's see, let's pretend it was 1,000 processes. As you see, in this other universe, still the owner wasn't happy. It was not that what he needed. And in the first universe, he wasn't also happy because they told him, it was working. Why do you try to spoil the thing that is already working? Don't make it better. It's good enough. But okay, that's the lesson. Never do this beyond if you are not asked. So after a few days of operations, let's now go to the do I have a counter somewhere? How much time do I have? Okay. After a few days of operation, what happened? Power cut! Power cut! And you know, these guys from the other universe said, oh, everything we have in MySQL, MySQL is reliable, everything will be fine. But the guys from the normal universe, besides this one experience, were just shocked. What now? Do we really believe? I have 5 minutes. Oh, that's bad. So what has happened? They seen this picture in this normal universe, and after that they see this picture, and then they said, "Oh, thanks God, we have this all on the notebook. So this has hibernation, so memory is preserved, no problem." Works. As you see, sometimes the simple solutions are okay. So, but after a couple of days, the next problem came. The owner said that he doesn't trust the pizza boy, so he wants to know to which planets he delivers pizza. So, the guys from other universe said, okay, they will never delete orders again. They will mark them as deleted, or even create some other table with deleted orders. Yeah, can be done like this. And these guys from a normal universe, they said, okay, we'll change our take orders procedure to store somewhere what was processed. By the way, they said, okay, that's data that's not really important for us, for the application. It's only for the report, for the owner. It's not really operational data, what was processed. It's some kind of report. And you know what can you do with not important data for application? You can store it in database. So they decided to, by the way, in this method processing that, store it in some kind of SQL database. So, and then they restarted the system. And all this lambda were processed. And by the way, in this normal universe, it means from the start of the system, it was happening exactly the same as was normally happening, but besides the orders, the things that were stored, preserved in some kind of table in some other database. So what happened? Both teams realized, and the owner says, so I know this, I want this data for yesterday. And you know, in this other universe, they say, sorry, till yesterday we are deleting everything. In the normal universe, they have this log of the events from the start of the system. So simply after restarting, it was there. Nothing was really deleted, never, because they have this event log. So another real-world case, let's skip, like making complicated pizza. What if, so for instance, customer can design pizza like half of then if you do it with a tables, you would see like, I don't know, something with 20 SQL tables or whatever. It would be horrible. So maybe they need a text field to store, I need a pizza where on the half there are mushrooms, whatever. If you do it with a Java, you can use, I don't know, builder pattern, whatever. You have a lot of possibilities, everything that goes in a Java, like doing abstract syntax tree of defining your pizza goes and will be preserved. So it's very flexible. So the difference at the end. Difference is like that. One normal universe is very fast, the other universe is terribly slow in comparison, even though it's way faster than the typical systems you work with. In the normal universe, you had most of the code in Java. In other universe, it was string annotation. By the way, yesterday I realized how can we call it. In the normal universe, we have strongly typed system. In other is stringly typed. So everything is strings. These SQLs in annotation. This one normal universe was very flexible, the other was limited. The one was very testable because you can easily test Java objects. It's really easy. In other, it's testing, for instance, either you use some kind of mocking. Mocking the database is a really horrible idea because at the end with HAPA, what do you test then? You test nothing if you mock. So you have to use database and it makes tests really not that easy. And there is one other difference. In this normal universe, they used sophisticated Java structures like priority queue, for instance, that you don't know because you are not from the normal universe. And the other universe, they had Java that was doing generally nothing. Can we call those alien developers really Java developers? I'm not sure. But why those universes were different? Long time ago, you know what that is? That's memory. The last memory that you can see every bit on your eye. Really, from 60s. And there was a sweet spot in around 90s if both galaxies that computers had mostly one CPU core, and memory was expensive, but something like 100 megabyte was available, but disks were huge at that time, 2 gigabytes or 20. So it was perfect time for something called JE or some object relational mapping. We can process information of disk because we need something like 2 gigabytes, but in order to make it simple, let's pretend it all's done in a RAM. So we have this object relational mapping with databases. That was really sweet spot for golden era of databases. They really made sense at that time. Around Galactic year 2003, what happened? In a normal universe, RAM became relatively cheap, more and more with every year. And computers had multiple cores, and you could use that power in applications. So they realized they have so huge amounts of RAM that they don't need databases anymore to process this data. Yeah. And because everything fits in RAM, so if they only preserve the events, it's everything fine. Yeah, on the other universe, RAM was cheap and huge. Computers had multiple cores, and nobody realized. That is like that. They were doing like the fathers because, you know, that's called cargo cult. Nobody really thinks, oh, my fathers were doing like this, it must be okay. So other universe, by the way, it's a very good place for database vendors. They are happy. Application servers vendors are happy. Power plants are very happy because hey, they have to provide power for all these servers. So hardware vendors are happy, of course. These guys selling this stuff are happy. Business complains like this domino, but still has to pay. And developers, you know, they have a lot of more work to do, so they are happy. It's why to change it? But then I see these problems like you have on the picture, yeah. Like somehow they are not satisfied with Java. Okay, there are of course problems. Also, some kind of problems that you have, maybe encounter with object relational mapping, you have also with this prevalent normal universe. It happens. So I won't go to the details, but there are some similarities. So if you struggle sometimes with object relational mapping, similar problems will appear in this, also in this normal universe. Besides, all will be way faster. And if you look at the code of the typical system, this code of the object relational mapping world and with database and the normal would be for a long time similar, the same amount of code. And in one moment, because of performance things, the other universe becomes complicated because they have to fight with problems with operational mapping, performance, etc. And the normal universe doesn't have to fight with that. And then it makes really a huge difference on the amount of code that you have to maintain. Okay, if you want to jump to the normal universe because you are not there, you are not a Java developer, in fact, there are some simple ways to start. Something very, very old story. It's called Previler library for this persistence. So this easy persistence, it's called Previler. There is a web page, you can read about it. ArrowMem, that's my thing. It's simply the Previler, but with wrapper for Java 8 that you can use easily this lambda expression. But it's really nothing more. It's very short library. So Previler is very easy. You can write it on your own. So the third solution is use this and implement it on your own. That's the best idea. Because then you will understand how it works. It's very easy. That's like 1,000 lines of code. It's not that much in comparison what you do typically, and you have the same. But if you are lazy, you can use something ready. So I will skip it. Everything you will see it on GitHub, how it works. By the way, I told you you can do it easily with lambda expressions. Don't do it with lambda expressions. You should generally write full classes here, like execute and query, and instead of a small lambda elegant, please use the whole class. That's because of some limitations of Java serialization, because this is perfect for prototyping, showing something that works. This is safe for productive use for years. That's the difference. So you can, of course, make some shortcuts to show, but then if you go to production, switch all the lambdas to this. Just, there is a reason for that. Concurrency and everything is okay. By the way, it's not really a problem that you have one thing at a time. Still, as I've shown you, it's more faster than concurrent thing on the databases. Because, yeah, it's so fast to do operation in memory. Queries are executed concurrently with write, so it means you need things like this atomic long, if you share something with read and write operations. By the way, at the end, the data is stored on the disk like this. Journal means some events, and by the way, it's not like one event here, like one second event here. No, it's like, I don't know, 10 events here, then 100 events here, then 100 events here, and then it's a snapshot. Snapshot is, if I am doing it every day, and then you restart it after a year, maybe replaying all these events from this log would be horribly slow. So we can make a shortcut. Let's make sometimes, like maybe every night, a snapshot. So let's save all this system, maybe 20 gigabytes to disk. That's our snapshot. It means next time the system is restarted, start from the snapshot, recent snapshot, and then events. So mostly it's used in some kind of failures. Problems, by the way, you think you need incredible amount of RAM to do it, because your system exists in one moment in RAM. 5 terabytes you can order. It works even with Java, so no problem. And 5 terabytes is a huge amount of RAM, a huge amount of data. So skip it. Transactions you have better than in databases. By the way, you have to learn synchronization and concurrency, so more complicated Java. And it's still, even if you don't do systems like that, it still makes sense to learn it, because it's quite interesting. You will be better developer if you learn it. Okay, replication is easy with that. If you think I need some kind of indices, there is even so you don't. Priority queue was a special index I really implemented here, but there are some ready structures. So hash map that you can, for instance, you sort faster using this column or whatever. There is special project called CQ Engine. You can use that. So it's like making fast query in memory with Java data, with Java structures like lists or hash maps. Yeah. By the way, who has heard about CQRS? So what I've shown here is, I would call it poor man's CQRS. CQRS is the full enterprise version of this approach, like event sourcing and yeah. So this is, but if you read about CQRS, that's great technology. I would say very safe on production. There are lots of systems with that, but the learning curve is steep. It's really not that easy to make a first move, the first system. So this is easy CQRS for you. You can start with that, and then if your system becomes really huge, you can switch to the CQRS that you can read about a little bit more. But you will be familiar with the problems, how to design a system. Yeah. So advice from me, always if you do systems like that, they are so fast that remember to put thread sleep often, because if user saves something and immediately responds, then they think it's fake, it wasn't saved. So that's my solution. If then somebody says it's too slow, then you can easily fix that. By the way, what's the difference between this and isn't this simply a database? There is a huge difference. What is the source of truth? In database, you store the state. You model it, and this is a state in table. If it's MongoDB, SQLDB, whatever, that's the state that you preserve. In this system, the state is only temporary thing in memory. You preserve events, and that makes a huge difference. That's the philosophical change of thinking, that you need to learn that. By the way, there are some enterprise alternatives. New framework, I recommend it, Lagom from TypeSafe. That's Lagom, that's for Java. It uses CQRS approach. It's very, very funny to try it. It's really an enterprise-ready product. So, and it's open. Also, I don't know it's open source. Surely it's free to use. I think it's open source. Akka persistence is the same approach for Scala for Akka. You can also use it with Java. And CQRS generally, the best guide describing is Greg Young. I recommend his talks. But this is the how to make it enterprisey. This what I've shown is great for startups. Until you grow, this system isn't somehow limited. But I would say it doesn't have everything ready. Right? Replication you have to do on your own. So maybe in one moment you may switch to this solution if you see that you need something more enterprisey. But okay. So the end, try it first on something small. You can be incredible efficient, you can do incredible system, but start on something small because this completely other way of thinking. And if you do it from the start on some kind of new important project in your company, you may fail because you are not ready for this other way of thinking. I don't know. My first system were not really good designed. I needed some 1 or 2 systems to really find out how it works. It's generally with CQRS because it's other way of thinking, and I think that's all. So just drop magic, forget, make Java normally. That's my message to you. So are there any questions? Or do we have no time more? Okay, questions? You can of course ask me later because I can talk you more and more about this. Yeah, so some stories from the real life. By the way, there are great big companies doing that. So, for instance, the LMAX exchange, you maybe thought. Of course, it's not using my Arrow provider, but they generally process data in memory and use these databases only for storing things like for reports. And they have a heap like 40 gigabytes and with really hot data. Yeah. So, and there are more systems doing that. So, really, memory and preserve events. And do it very quickly, incredibly quickly. Yeah. Okay, so thank you.